Welcome to lecture 58. In this final week of 12, we are talking about software tools for optimization. In our previous two lectures, we have talked about Microsoft Excel Solver as an optimizer. We have seen how to use Excel Solver to solve unconstrained and constrained optimization problems. We have seen both single variable and multivariable optimization problems. In today's lecture, we will learn how to use Microsoft Excel Solver for solution of linear programming problems. So, let us consider this linear programming problem. Maximize f equal to x 1 minus x 2 plus 2 x 3 subject to three constants 2 x 1 plus 3 x 2 less or equal to 500, x 1 plus x 2 plus x 3 equal to 200 and x 2 plus 10 x 3 is greater or equal to 100. So, we have one less or equal to type constant, one equal to type constant and one greater or equal to type constants. Then we also have x 1 greater or equal to 0, x 2 greater or equal to 30 and x 3 less or equal to 4. So, the first task will be you launch Excel Solver, make sure that solver is loaded. We have seen in previous lectures how to do that. And look at these columns A, B, C, etc. Now, after you have formulated a linear programming problem, we have to enter the problem into Excel sheet. A good approach to entering the problem into Excel sheet is to use column A to fill labels such as upper bound, lower bound, value, objective function and constants. You can expand the width of column A if necessary. So, what I mean is that what you can do is you can use this column to write variables, upper bound, lower bound or the values of those variables, then the constants. So, these labels we can enter in column A. In column B onwards, we can type the variable names. Suppose there are three variables x 1 and x 2 and x 3. So, we can write these things in column B, C and D. We can also put the right hand side constants on the columns after that. So, in cell A1, let us type something to identify that this is a linear programming problem. You can give a name to this linear programming problem. Suppose in cell A1 you write linear programming problem example 1, so on and so forth. In row 1, starting at column B and moving right, enter a name for each variable. Use one cell for one variable name. The labels can be descriptive such as regular fuel, premium fuel, etc. or the label can also be generic such as variable 1, variable 2, etc. You can also give names such as x 1, x 2, etc. So, whatever is convenient, you can accordingly give labels for variable names. So, either you can give descriptive names such as regular fuel, premium fuel, product A, product B, etc., or you can give x 1, x 2, x 3, so that you can easily identify them. So, after you have entered the variable names starting from column B. You now move right, skip a cell and type evaluations. So, after you have completed writing the variable names, you skip a cell and type evaluations. Then skip another cell and type right hand side constants. Note that this skipping cell is not compulsory, but it will be convenient for us if you do that. In cell A3, type upper bound. This row will contain upper bounds for the variables. You will be filling column A with levels. As we discussed in the beginning, that column A will be filling with levels. Upper bound is one such level. Similarly, we will put lower bound, we will put values. So, these three levels we will use for variables in column A. So, in cell A3, we typed upper bound as levels for the variables, upper bound for the variables. In cell A4, we type value. This row will contain the values of the variables. So, these are values of the decision variables. This row will be adjusted by the solver in solving the problem. So, finally, this row will contain the solution of the problem, and initially you supply the initial guess for the problem in this row. So, in cell A5, type lower bound. So, this row will contain the lower bounds for the variables. Suppose you have three variables. So, in cell A3, you have typed upper bound. So, B3, B4 and B5 columns will have the upper bound values for the variables. Similarly, in the cell A5, you have typed lower bound. That means, this is row 5. So, in the cells B5, C5 and D5, you will have values for the lower bound of the variables. So, this will be more clear when I show you the picture or the snapshot of the Excel sheet. In cell A7, type objective. This row contains the cost coefficients in the objective function. Starting at cell A9 and moving downwards, add one level for each constant. Each level can have a specific name such as storage, time, etc., which describes the constants, or you can supply a generic name such as constant 1, constant 2, etc. So, this is what the Excel sheet will look like. In column A, you have given the labels. Column B, C, D contains names of the variables, variable 1 or x1, variable 2 or x2, variable 3 or x3. Column E, I have kept blank. Column F contains evaluations, column G blank, and column H contains right hand side constants. So, this is more clear. So, you can note that the column A contains all the labels as we discussed, and column B, C, D contains variable names, column E is blank, column F contains evaluations, column H contains right hand side constants. So, these three cells will contain the upper bounds for variables x1, x2 and x3 respectively. These three cells will contain lower bound for decision variables x1, x2 and x3. These three cells will contain coefficients of the objective function, and these 3 cells will contain coefficients of the constants, constant 1, constant 2 and constant 3 respectively. And these 3 cells initially will contain initial guess for the solution, and finally will contain the converged solution. So, evaluations will contain the processing of the objective function and the processing of the constants. The right hand side constants of the 3 constants will be contained in column H under RHS constants. So, this is the structure that we are following. Note that you can also use a different structure, but I think this is convenient. And the labels that I am using again are not fixed labels to be used. You can use your own labels according to your choice. So, now put values for upper bounds and lower bounds. So, you can see a zoomed version here. Note that the upper bound for x 1 and x 2 I have put as 10 to the power 25, because there was no upper bound mentioned in the original problem. If you remember the problem formulation, it was written x 1 greater or equal to 0 and x 2 greater or equal to 0, sorry, x 2 greater or equal to 30, x 1 greater or equal to 0 and x 2 greater or equal to 30. So, there was no upper bound. So, I took a large upper bound 10 to the power 25. X 3 was given as x 3 less or equal to 4. So, that is why upper bound for x 3 has been put as 4. You can supply the initial guess for values variable x 1, x 2, x 3 all as 0. If you keep blank, it will be taken 0. And the lower bound x 3 is greater or equal to 30. So, lower bound of x 2 greater or equal to 30. So, lower bound of x 2 is 30. No lower bound for x 1 and x 3 is given. So, we consider non-negative values for the variables and consider x 1 and x 3 have lower values as 0. So, I have now put the values. Now, click on the cell B7, that means the row which contains objective level. Row 7 will contain the cost coefficient for each variable. So, we enter 0 if there is no cost coefficient for a variable. So, this proceed to the right to fill row 7, that is objective row, with cost coefficients until every column with a variable name has a cost coefficient. So, if you remember, the objective function was maximize x 1 minus x 2 plus 2 x 3, x 1 minus x 2 plus 2 x 3. So, the cost coefficient of x 1 was 1, of x 2 was minus 1 and of x 3 was 2. So, those are the values I have put in row 7, where in column A objective variable, objective level is written. So, these values you have to put. Now, we have to enter now constraint coefficients. We have, as of now, we have entered the variable names, then we have entered the upper bound, lower bound and initial guess for the values. Then we have entered the cost coefficients of the objective function. Now we have to enter the constraint coefficients. So, you have to look under constraint row. So, start from row 9, which contains constant 1. Enter the constant coefficient of each variable in the cell with the matching column. That means, under variable x1, x2 and x3, the column B, C and D. Now, skip 2 columns and enter the sign of the constants in the cell. The constants may be greater or equal to or less or equal to type. So, appropriately you put in the column G, and then in column H, which contains right hand side constants, you put the right hand side constants for these 3 constants. For constant 1, it was 500, for constant 2, it is 200, and for constant 3, it is 100. So, this is how it will look like. Note that I have put the constraint coefficients, and then I have indicated what type of constraints are they, less or equal to, greater or equal to, and the values of the right hand side constants for constant 1, 2 and 3 respectively. Now, we have to process objective function. Now, you have to put a formula under evaluations column for processing objective function. Find the cell in row 7 which contains the label objective. You can also write objective function. So, find the cell in the row 7 that is also in the column labeled evaluations and click on it. Type equal to sum product, then first bracket, but do not press the enter key. Click on cell B4 containing value and hold, dragging right across the row until every column with a variable name is inside the selection. Release the mouse button, press the comma key. Now, click on cell B7 containing objective and hold, dragging right across the row until every column with a variable name is inside the selection. Release the mouse button, type closing first bracket and press the enter key. The number 0 should appear in the cell. Basically, what we are doing is, if let us say I have 3 decision variables x1, x2 and x3 and the cost coefficients are C1, C2 and C3. You are basically finding out C1 x1 plus C2 x2 plus C3 x3. Now, similarly, we have to process constraint functions. Now, we have to put formula under evaluations column for processing constants. Start at row 9 containing constraint 1. Find the cell in current row that is also in the column labeled evaluations and click on it. Type equal to sum product and starting first bracket. Click on cell B4 containing value and hold, dragging right across the row until every column with a variable name is inside the selection. Release the mouse button, press the comma key. Click on the cell in the current row that is also in column B and hold, dragging right across the row until every column with a variable name is inside the selection. Release the mouse button, type closing first bracket and press the return key. The number 0 should appear in the cell. So, this is very much similar to what we did in case of previous step where we processed the objective function. So, similarly, we have to process all the constant functions. So, repeat what we did for constant 1, for constant 2 as well as constant 3. So, basically you are multiplying the decision variables with their corresponding constant coefficients. So, this is how it will look like. Under evaluations, all zeros are coming because the initial guess for x1, x2 and x3 I have taken 0. So, every coefficient is getting multiplied by 0. So, we are getting sum product as 0. So, this is how it will look like after processing objective function and constant function. Now, we have entered all the data and we are now ready to solve the problem. From data tab, click on solver and the solver dialog appears. And what you see now is the dialog box, and this is for bit older version of Excel solver. I will show you how the new version or the last say 2013 version will look like. So, from the data tab you click on the solver and the solver dialog box will appear. You have to set solver parameters here. Click on the cell in the objective row, row 7 under the column heading evaluations. This reference of the cell should be in the set target cell. So, the first thing that you have to do is you have to set the target cell. So, for setting target cell, you have to click on the cell in the objective row, row 7 under the column heading evaluations. The cell reference of this cell should be in the set target cell box. So, this is how the dialog box for the newer version of the Excel solver will look like. Again look at the dialog box. In the equal to section, decide whether you want to maximize or minimize the value in the cell by selecting the corresponding radio button. We are maximizing our problem, so we select max radio button. Click inside the text box directly under the text by changing cells. Select the adjustable cells which is our value row, row 4. Remember, the row 4 or the row with objective value under column A contains the adjustable cells, the variables x1, x2 and x3. So, that is B4, C4 and D4. You can actually click on this red button and then click on B4, drag it up to D4, release the button, you will get this. So, this is how the newer version will look like. Now, we have to set the bounds. Actually, this will be done by setting constants. If you look at here, there is add button in both the versions. So, this add button is used for selection of the constants or for entering the constant to the solver. So, let us first see how do you set the bounds. In the subject to the constants box, click add. This is where the solver picks up the constants. Let us first set the upper bounds. Click the icon with the red arrow under the cell reference text. This icon is the leftmost of the two identical icons. Click and hold over cell B4, that is the row or with the objective value, and drag to the right until all variables have been selected. Release the mouse button, click the icon with the red arrow to go back to the constraint window. Now, you have to indicate whether this is less or equal to, greater or equal to, or equal to type constant. This is less or equal to type. So, you select less or equal to from the drop down menu. Click the icon with the red arrow under the constant text. This icon, the rightmost of the two identical icons with red arrows. Click and hold over cell B3, that is the level with upper bound, and drag to the right until all variables have been selected. Release the mouse button. Similarly, complete all the lower bounds. Similarly, you will complete for the lower bounds. While you do for the lower bounds, you have to choose greater or equal to from the drop down menu. Note that the upper bound is something like less or equal to type constant, but lower bound is greater or equal to type. So, that is why you have to choose the appropriate sign, less or equal to or greater or equal to from the drop down menu. So, now in a very much similar way, we have to set the constants. Click the icon with a red arrow under the cell reference text. Before that, you must have typed add. So, click the icon with a red arrow under the cell reference text. Click the cell in a constant row that is also in the column under the evaluations heading. Click the icon with the red arrow to go back to the constants window. Select the matching entry less or equal to or greater or equal to from the drop down list. Click the icon with a red arrow under the constraint text. Click the cell in the same row as the cell you clicked above, but in the column after the right hand side constant heading. Click the icon with the red arrow to return to the constraint window. Click the add button. So, this way we can set the constants. So, all the constants has to be set following the same procedure. So, after you have put all the constants, your dialog box will look similar to what you see on the screen. This is for the older version and this is for the newer version. Now, click the solve button. Microsoft Excel will find the optimal solution to the problem that you have specified. Click keep solver solution option and also click answer under reports, then click OK. For the newer version, you choose Simplex LP from select a solving method menu. So, choose Simplex LP from the drop down menu, then click solve. You can check the box saying make unconstant variables non-negative. So, when you click solve, Microsoft Excel will find the optimal solution to the problem that you specified. Click on keep solver solution and click on answer under reports, then click on OK. So, then this is the solution you will get. A zoomed version will be clear. So, the optimal values of x1, x2 and x3 are 1, 3, 6, 60 and 4 respectively. Optimal value of the objective function is 84. Note that all the constants are satisfied. First constant was less or equal to 500. So, the value of the constant for these x1, x2 and x3 is 452. So, which is less than 500. Second constant was left hand side was equal to 200. So, satisfied. The third constant was constant 3 was greater or equal to 100. So, that is also satisfied as equality. So, you have clicked on answer report. So, this is the answer report which is self-explanatory, contains the solutions and informations about the solution such as 3 iterations were required. It tells you that which constants were binding, which were not, etc. Now, apart from answer under reports, you also have sensitivity. You can also click on sensitivity to get a sensitivity report, and this is what you will get. Sensitivity analysis gives you insight in how the optimal solution changes when you change the coefficients of the model. So, if you change certain data in the model, how the objective function value, optimal values of the objective function will change, that insight you will get from sensitivity analysis. There are 3 important things to look at: reduce cost, allowable increase, allowable decrease and the shadow price, also allowable increase and allowable decrease. So, we have to study these to understand the sensitivity report, and we will do this in the next lecture when we demonstrate the solutions of this linear programming problem. So, with this we stop lecture 58 here.